Push an artificial intelligence server or a rocket engine to its limit, and it generates enough heat to trigger a physical meltdown of its circuitry. To prevent these systems from destroying themselves, engineers require a medium that can pull that heat away from the hardware instantly. Helium is the only solution. It stays liquid at nearly absolute zero, the lowest theoretical temperature, providing a thermal sink that no other element can match. This extreme cold is what stabilizes the massive magnets inside hospital MRI machines and maintains the atomic-level precision required to etch modern semiconductor chips. When this supply fails, MRI magnets quench and chip manufacturing tolerances vanish, freezing the physical progress of the medical and digital sectors. In early 2026, the global supply chains for this liquid coolant fractured. The shock exposed vulnerabilities in India's push for self-reliance, directly threatening the viability of its domestic space missions and healthcare networks. This scarcity transformed a technical gas into a geopolitical leverage point. Helium presents a physical contradiction. While it is the second most abundant element in the universe, it is vanishingly rare on Earth. Over millions of years, trace amounts of the gas are trapped deep underground, locked inside specific rock layers alongside natural gas deposits. We cannot manufacture helium. We can only extract and purify it as a byproduct of processing that natural gas. This geological luck concentrates the world's supply. Today, the United States and Qatar operate as a global duopoly over the market. This chart shows the scale of the bottleneck. Before the recent disruptions, Qatar alone provided roughly 1/3 of the total global supply. India produces almost no helium domestically. Every MRI scan and satellite launch in the country depends on these specific import lines remaining open. Geographic concentration turns a standard industrial commodity into a fragile choke point. In March 2026, regional conflicts forced the abrupt shutdown of major Qatari extraction plants. As a third of the global supply vanished, prices spiked. The timing was disastrous. Demand for helium from global AI chip manufacturers was surging faster than any new plants could be built. At the same time, the race for quantum computing increased the need for helium-3, a rare isotope that India requires to compete in high-stakes computation. India found its sovereign technological ambitions tethered to a global supply chain that had effectively closed. For years, firms and governments prioritized the low cost of imported helium over the massive capital required for domestic exploration. This reliance on just-in-time logistics left no room for the multi-year stockpiles needed to weather a supply freeze. This manifests as a ground-level crisis. When reserves run dry, hospitals are forced to power down scanners, and precision manufacturing slows to a crawl. Policymakers must now choose: pay exorbitant rates for emergency imports to stay online today, or accept significant delays to fund long-term domestic infrastructure. While recycling can recover a small fraction of the gas used in these processes, it cannot bridge the massive deficit created when the primary taps are shut. The dilemma is a trade-off between immediate industrial convenience and the high cost of technological sovereignty. India's response to the 2026 shock was a pivot toward its own natural gas fields, aggressively searching for domestic helium recovery sites. The government is now prioritizing heavy investment in long-term stockpiles and recycling over a total reliance on foreign markets. The crisis proved that energy extraction policy is a core component of technological destiny. Securing the future of artificial intelligence or spaceflight is only possible if a nation can first secure the thermal environment that allows that hardware to function.